So thanks a lot for the invitation to Exeter. I'm very pleased and feel very privileged to be here and to present the results of the Working Group 3. And I'm also quite impressed by your tolerance to listen to a Catholic Bavarian. So this is something which was, from my point of view, one of the big challenges. So I had a training also in my previous life in philosophy, and I have to admit to bridging the different expertise and the different value systems within the IPCC, philosophy was one of my huge and the most important capital endowment for this exercise. And being trained in philosophy was, at least to be a co-chair of Working Group 3, much more important than to be an economist. Now, let me start with one important observation. So when we talk about the Working Group 3, this is something where we have to deal with facts and values at the same time. And this is really a huge challenge. And therefore, within Working Group 3, we have developed a kind of a metaphor, which I would like to share with you. And the metaphor is the metaphor of a map maker and a navigator. And within Working Group 3, as scientists, we perceived ourselves as map makers. Map makers who try to explore different pathways to different goals, and instead of prescribing a specific pathway, we want to be explicit about the underlying risks, the underlying costs, and the underlying opportunities of these different pathways. This was the only way how we have been able to deal with facts and values at the same time, because if somebody believes, and there are people in the working group, they believe that, for example, nuclear power is an inevitable component of mitigation, so then we haven't tried to achieve a consensus about this specific issue. Instead of that, we have tried to be explicit about the underlying risk and the underlying costs and the underlying opportunities of this specific pathway. So this is, from our point of view, quite important, because as a map maker, we want to be useful and to offer a map to the navigators. And the navigators are the decision makers, the policy makers, the public. And we hope that we can facilitate a more rational debate about these different pathways and to facilitate a more rational debate on this issue, how to achieve specific low stabilization goals. And as you know, this, on the one hand, this metaphor of a map maker and a navigator was quite useful because it helps us to avoid wrong consensus, false consensus, and it allows us to remain scientifically credible. On the other hand, we had our big fights with the governments during the approval session when we proposed our exploration of the whole solution space. So, and there are some problems because some governments, or many governments, have deleted some material in the summary for policymaker, but it is worthwhile to highlight that the technical summary and the underlying chapters have been totally unaffected by this. So you can read the summary for policymakers, and in the summary for policymakers you have the consensus between the scientists and the governments, and in the technical summary you have the consensus between the scientists, what scientists want to tell to the public and to the policymakers. And then you have these 16 chapters which can be understood as the maps which has been drawn by the scientists. I think this is a reasonable starting point to understand the Working Group 3 contribution to the IPCC, to the fifth assessment report, and at the same time, as a very rough introduction, how we have tried to deal with facts and values. Now let me start with a few insights. Now first of all, and this is a quite important insight, what we can see is greenhouse gas emissions accelerate despite the financial crisis and despite of the reduction efforts around the globe. So most emission growth is CO2 from fossil fuel combustion, And in the last decade, we had the highest growth rate in economic history, and energy supply and industry are responsible for 3/4 of the increase of emissions. So then we try to have a look on the history from 3 different perspectives. And the first perspective is on the cumulative emissions. The cumulative CO2 emissions have more than doubled since 1970. And what you can also see is that Asia becomes, in terms of the cumulative emissions, an important player over the last 3 decades. So, but you can also look now a little bit more on the most important underlying drivers of emissions. And the most important driver, I will come back to that in a minute, the most important driver is income. And therefore, we decided to decompose the different regions along the income categories: low income, lower middle income, upper middle income, and high income. And very roughly what you can see here in this picture is that all the low and upper middle income countries replicate the economic history of the high income countries. Basically, there is no leapfrogging, at least when you look at the historical data. Since 2000, greenhouse gas emissions have been growing in all sectors. For most low-income countries, the largest source of emissions are from the agricultural sector, and the share of the energy and industry sectors increase for lower middle-income countries, and these are the largest sectors for the upper middle-income countries. And the transport sector becomes a large sector for high-income countries. And it will turn out when we analyze the mitigation pathways that the transport sectors is the most costly sector to be decarbonized. Now, the next graph is a quite complicated one, because here we have analyzed the national per capita emissions. And here I would like to draw your attention just to this graph here. But you can see here, these greenhouse gas emissions per capita are highly variable within and between income groups. So you have here a high variability within the low income group, and here also with the high income group. The variability within the low income group comes from deforestation, from the different deforestation patterns. And in the high income group, the variability comes basically from policy choices. So this is also a quite important issue to understand, that for the high income countries, policy really matters. Now you can look also, when you analyze the history, a little bit from a part of the international trade and the international division of labor. And what you can see here is that the high income countries are the main importers of emissions, and the upper middle income countries are the main exporter of emissions. So for example, in China does not only export capital and goods to Europe and to the United States and to the other OECD countries, but it also exports emissions. And you can see here this kind of production and consumption-based accounting mirrors, so to say, the international trade pattern and the international division of labor. This was a very important debate, even during the approval session, because it's quite clear that economies in transition want to have a more consumption-based accounting, and high-income countries prefer a little bit more production-based accounting. But in the end, it doesn't matter. What this figure clearly shows is that if emissions are embedded in an international trade pattern, you need a kind of a global agreement, of a global economic policy to deal with the increase of greenhouse gas emissions. Now the next one. Again, this is about the global emissions, and here we have decomposed the global emissions growth into 4 components: the carbon intensity of energy, the energy intensity of GDP, the GDP per capita, and population. What you can see here is that the most important drivers for CO2 emissions have been population and economic growth, and in the last decade, income is the most important driver, despite of the fact that we have seen over the last decades a remarkable reduction in energy intensity, or the other way around, an increase in energy productivity. There have been a lot of progress in the increase of energy productivity, but this has been all the time overcompensated by economic growth and population growth. We have also seen in the last decades a remarkable decline of carbon intensity due to the fact we have seen more gas in the power sector instead of coal. But in the last decade, we see, even during the financial crisis, an increasing carbon intensity. And this increasing carbon intensity remains for the next few years, and we expect that the carbon intensity will increase further. And this is due to the fact that we are in the middle of the largest coal renaissance since industrialization. We have seen an increasing competitiveness of coal in India and China and in the United States. And this is really one worrying fact when we analyze the emissions. Despite of mitigation efforts, despite of the financial crisis, we see that coal remains the king, at least in the current energy system. Now, what about the mitigation efforts? The message here is quite simple. Without mitigation, global mean surface temperature might increase by 3.7 degrees to 4.8 over the 21st century. And it is also important to understand that even if we go just for a 3-degree target, we need a substantial change, a substantial departure from the business as usual scenario. And if we go for the RCP 2.6, we need even negative emissions in the second half of the 21st century. This is a huge challenge, but even a 3-degree target is a huge challenge, and it requires a dramatic departure from the business as usual scenario because we are on a high carbon track. Now, what does this mean, this emission profile in terms of technology? Again, it is quite simple to understand. Here you have the different, here you have the different stabilization pathways. And if you go for a 430 to 480 ppm CO2 equivalent scenario, what you can see here is you need a dramatic scale up of low carbon energy share on the primary energy. So compare to the current level, but also compare between the business as usual scenario and any kind of a meaningful stabilization scenario. Admittedly, these are long-term scenarios, and the IPCC has a remarkable reputation to think about the long-term issues. But as your fellow countryman John Maynard Keynes always said, in the long run, we are all dead. And therefore, we decided to think a little bit more carefully about the relationship between the short-term and the long-term issue. Here again, what you can see here, all these different stabilization pathways are consistent with a 2-degree target, roughly with a 2-degree target. So you can say that even the Cancun pledges are consistent with a 2-degree target. However, whatever we will do until the next 2 decades determines what we have to do then after 2030. So if we remain for the next 2 decades along this line of the Cancun pledges, so then we need an emission reduction growth rate around -6%. This is something which is, given the historical experience, it's an unprecedented level of emission reduction. So this is the current emission reduction, what we see now historically. So this means the lazier you are now, so the more emission reduction is required in the future. And this has, again, a strong implication, this has a strong implication for the upscale of the low carbon technologies. You need here a dramatic upscale if you want to achieve a -6% emission reduction growth rate per year. So, and this is what we call in the working group 3 as the mitigation risks. Upscaling has inherent risks of mitigation. If you scale up carbon capture and storage, if you scale up bioenergy, even if you scale up variability of renewables, this has inherent risks which translates in higher adjustment costs. And this has to be taken into account. And what the basic message is that the current Cancun pledges imply increased mitigation challenges for reaching a 2 degree. Many people within and outside the Working Group 3 had a tendency to say IPCC should communicate to the world the 2 degree target is no longer feasible. What we decided to say in the Working Group 3 is not to talk about feasibility or non-feasibility. We tried to be explicit about the underlying technological, political and institutional requirements for a 2 degree target and even for a 1.5 degree target. And this is here the part of the economic and the technological requirements. And this is up to the public and to the decision makers to decide to what extent these requirements can be fulfilled. Now, the next one is about costs. As economists, and in particular in Working Group 3, we are interested about costs. So first of all, what we did is we calculated the costs under very favorable assumptions. And what are the most important favorable assumptions? You have all the technologies available. You have a full and a broad portfolio of technologies on the one hand, and you have no delay in international action. And if you assume that this can be fulfilled, so then you come up with cost estimations in the median around 3.5% for achieving a 450 ppm CO2 equivalent by 2100, relative to the baseline. And this cost estimation translates into a reduction of the consumption growth rate over the 21st century by about 0.06%. So let's assume that you have a 2% GDP per capita growth rate. Then this means that you have then a growth rate of 1.9.4%. So this means that economic growth and the reduction of emissions in general can be reconciled, and you can basically have both. But this comes with a price, and the price is the delay of economic growth. And also these cost estimations exclude the benefits from mitigation, because this was the mandate of Working Group 2. And they also exclude other benefits, for example, like the improvements for local air pollution and other short-term co-benefits. I will come to this point later on. However, these cost estimations are based on a series of assumptions, and I mentioned already 2 of them: the availability of technologies and immediate international action. But what happens with the costs when we have, for example, not the full portfolio of technologies available? And this kind of scenarios allows the policymakers to understand what kind of technologies have the largest potential to increase the mitigation costs, or the other way around, what kind of technologies have the largest potential to reduce the costs of mitigation. And here I would like to emphasize one cluster of technologies for low stabilization. This is carbon capture and storage. I know this is, at least in Germany, a technology which is definitely not everybody's darling. However, within low stabilization targets, we need carbon capture and storage for 2 reasons. The first reason is we are now on a coal pathway, and in order to deal with the enormous amount of coal around the globe, many countries need carbon capture and storage, and carbon capture and storage has to be combined with bioenergy, because given the current knowledge, this is the only option which allows us to absorb CO2 from the atmosphere. It's also interesting to see that if there is no expansion of nuclear energy, the costs increase are moderate, and also renewables, they are important in all the scenarios, and they are also quite important even in the business as usual scenario, and therefore a little bit more limitation on them has not the hugest potential to increase costs, but the limited availability of bioenergy has also a large potential to increase the costs. Now, what about the short term and the long term? And I think in the IPCC we have entered here a new territory, but it seems to me this new territory should be explored in future assessments much more carefully. And this is the relation of long-term and short-term benefits. And the improvement of local air pollution, and we have seen and assessed some of the scenarios in the Working Group 3, is a very reasonable entry point for climate mitigation, in particular in China and in India. But there are much more other short-term co-benefits which are quite promising when we think about a tax policy which includes, for example, a reasonable design of carbon capture and storage, a reasonable design of the CO2 tax, and when the revenues are used, for example, for infrastructure investments in public health and in education. Now, what about the requirements across the sectors? Mitigation requires changes throughout the economy. Efforts in one sector determine the mitigation efforts in other sectors. And this shows you here a different or the same message from a different perspective. Here you have the baseline emissions in the different sectors, in the transport sector, the building sector, the electricity sector, and in the agricultural sector. And then you have here both stabilization pathways, 450 ppm, without and with CCS. So you can, in the end, sacrifice, so to say, or you can avoid CCS, but this comes also with a price. What you then have to do is, you need more emission reduction in the end-use sector, you need much more reduction in the energy demand, and you put an additional burden to the agricultural sector. It is my feeling that this kind of information is quite important because policymakers have to understand that when CCS is not available for them, or they are not happy with the CCS because the public is risk averse, so then they have to communicate to the public. We have to do much more on the energy demand side and much more in the agricultural sector. All these transformation pathways have a strong implication for the investment patterns. We need a decline in the annual investment in the fossil fuel technologies, about 20%. And we need annual investments in low carbon technologies. And these investments have to rise by 100%, in particular in the non-OECD countries. Now, what about the policies? First of all, we have assessed many policy instruments ranging from sector-specific policies, efficiency standards, pricing systems, carbon taxes, cap and trade system. But in the end, the whole message boils down to one fundamental message, and this is, in the end, we need a reasonable carbon pricing. Without the carbon pricing and without international coordination and without international action, we cannot afford a 2-degree target. And here I would like to summarize my whole message with a graph from, this is not in the Working Group 3 report, it's in the special report on renewables. And I have to admit, this is one of my favorite slides when I have to explain the economics of climate change. So here you have basically the zero line, and below the zero line, you have the resources and the reserves of gas, oil, and coal. And above the zero line, you have the amount of CO2 which we have already released into the atmosphere. and the rest is basically the emissions within a business as usual scenario, which basically says that we will not use all the coal, all the gas, all the oil underground. However, what you can see here is that the renaissance of coal can continue for the next few decades because we have the resources and the reserves available. Or the other way around, the scarcity of fossil fuels, the scarcity prices at the fossil fuel markets will not solve the climate problem. Because the limiting factor in the 21st century are not the fossil fuels underground, it's the limiting disposal space of the atmosphere. And in order to define the atmosphere as a global commons, we need an international coordination, we need international cooperation, and first of all, we need a common perception that the atmosphere is a global commons. And from my point of view, it is very encouraging that in our SPM, all the governments in Berlin agreed that the atmosphere can and should be perceived as a global commons problem. It's in a footnote, but it is in the SPM. Now let me conclude what is my basic takeaway, my personal takeaway from this Working Group 3 report. And now, in the last 3 minutes, I take the opportunity to behave as a free man. So my conclusion, it's not the conclusion of the co-chair of Working Group 3, it's my personal conclusion. My personal conclusion is, it does not cost the world to save the planet. However, it requires a huge effort, the right incentives, and a lot of goodwill. Thanks.